Good morning friends, welcome back to Panika Tutorials. In the last video, I have discussed about a malloc function with a C program. I hope you have watched that video. If you did not watch that video or if you don't know those concepts, I request you to go back and watch that video and come back to this video. In this video, I want to discuss in detail about Calloc function with a C program. So I request everyone to watch the complete video for better understanding. What is the full form of Calloc? Which is a contiguous allocation, whereas the full form of malloc is memory allocation. First, let me discuss the generalized syntax of Calloc. Then I will discuss few programs related to that Calloc. Now, the generalized syntax is, it will return a void pointer same as malloc, and the name of the function you have to give it is Calloc. Okay, and the Calloc will take two parameters, one is n and another one is size, whereas malloc will take only one parameter, which is size. If you specify size, then suppose let's take that you have specified size as 20 in malloc, then 20 bytes of memory will be allocated. Whereas in Calloc, you have to specify the size of one block, then it will create n such blocks. I hope you are understanding. To make you understand, let me create a memory to store some 4 integer constants. So let me write the program. You have to do the typecasting because you want to store the integers, and you are using the name of the function is Calloc. You want to store 4 integers, so you are writing the n value as 4 here, and you don't know the size of int. You are writing size of int operator. Size of is an operator. Okay, now why I am telling you don't know size of a integer? You know that, sir, I know that in a 32-bit compiler it will occupy 4 bytes. If it is a 16-bit compiler, it will occupy 2 bytes. Yes, I agree, but you don't know this program in which compiler you are running. Whether you are running it on a 32-bit compiler or 16-bit compiler, you know. If you know, here you can write the value. Okay, now let's take the size of int is 4 bytes. Let's assume that you are running this program on a 32-bit compiler, then size of one int will be 4 bytes. Then 4 bytes of block, such 4 blocks you are asking the user to create. So totally you are creating 16 bytes of memory. That memory you want to store the base address in an integer pointer. If the memory is allocated successfully, then the base address or the starting address will be stored within the pointer p. If the memory is not allocated due to some issues, then null value will be written and null value will be stored in the pointer p. Okay, let's take that 16 bytes of memory is allocated contiguously to store 4 integers. Okay, let's take that the base address is 100, then next one will be 104, next one will be 108, next one will be 112. Okay, then the base address p will be stored in the pointer p. If the memory is not allocated, it will have the value null. Okay, now in the malloc, the default values will be garbage values. I think everyone know what is a default value. Whereas in Calloc, it will be zeros. Okay, this is the one of the difference in between the malloc and Calloc. The basic difference between the malloc and Calloc is, in malloc you will have only one parameter, whereas in Calloc it has 2 parameters, and in the malloc the default value will be garbage value. In Calloc it will be zeros. Okay, now I will discuss one C program related to the Calloc. So I request everyone to watch it completely. Let me erase this one to use this space to write the program. Okay, now you know that if you want to use any dynamic memory allocation functions such as malloc, Calloc, regalloc, free, you need to include a header file called stdlib.h. Let me include that header file. So hash include stdlib.h. Then if you want to use the functions such as printf and scanf, you need to include the stdio.h. So first you need to include all the header files. Then I am defining the main function. In the main function, what I will do is that I will declare the two variables I comma n. First, I will ask the user to enter the n value. So printf enter the n value \n. Okay. Then once the user has entered the n value, using the scanf function, I need to access it, or I need to store it in the address of the variable n. Now, once the user has entered the n value, you have to allocate the memory dynamically using the calloc function. I want to store some n integers, so I'm writing the return type as integer pointer, and the name of the function I'm writing it as calloc, and then I have to write n comma size of int. Then to store that one, you have to declare the integer pointer. So if the memory is successfully allocated, the base address or the starting address will be stored in the pointer p. If the memory is not allocated due to some issues, then null value will be returned and it will be stored in the pointer p. So you need to check it whether the memory is allocated or not. If p is equal to null, then you know that memory is not allocated. Then you have to write printf memory is not allocated. If the memory itself is not allocated, how can you store the elements or how can you do some operations on them? So you have to exit from the program. So you are using a function called exit. If it is not null, okay, then you have to store some elements in those locations, because by default it will have the values 0. So for I is equal to 0, I less than n, I plus plus, I will ask the user to enter the element. One element I am asking the user to enter the element. Then once the user has entered, it is my duty to store it in the address location. As the user is entering an integer, I am writing the format specifier as %d. I need to store in address, so I am writing p plus I. Okay. Now once the user has entered all these elements, I will discuss the flow of this program later. First let me write the entire program. Then I am declaring one variable called sum. I am initializing it to 0. Now what I want to do is that whatever the elements you have entered, I want to compute the sum of those elements and I want to display the output to the user. So I will write for I is equal to 0, I less than n, I plus plus, then I will write sum is equal to sum plus I. Okay. Then finally I will write printf the sum of the elements is, or the sum is, you can write \n, you can write some variable in the name of the variable. So you have got the sum and you have displayed the output to the user. Once the memory allocation is done, you are done with the program. It is your duty to release the memory. Okay, so you have to use a function called free and you have to pass the pointer which is pointing to that memory location. So you have to use the name of the pointer as p. Once the pointer means the memory is released, it is your duty to assign the null value to the pointer to avoid the dangling pointer problem. Then you have to write the get ch and you close the main program. Now let me discuss the logic behind this program. The user has entered or declared two variables because you know that the program execution will start from the main function. Then if you look at the statement int I comma n, so you are declaring two variables as I comma n as integers. As you did not assign any values, initially they will have the default values which is garbage values. Then you are asking the user to enter the n value. Let's take that user has entered the n value as 3 and you have written int star p, so you are creating or declaring a pointer p and you have used the calloc function n comma size of int. Let's take that you are running this running this program on a 32-bit compiler, then you know that 4 bytes of memory is required to store one integer, and you are asking the user to create such blocks 3. So 3 into 4, which will be 12 bytes of memory, will be created dynamically during the runtime. Let's take that the base address is 1000, then the next one will be 1004, next will be 1008. That base address, the starting address 1000, will be stored in the pointer p. If the memory is not allocated due to some issue, the null value will be written by this function and it will be stored in the pointer p. So that's why you are checking if p is equal to null, you are displaying an output as memory is not allocated and you are exit from the program. If the memory is allocated successfully, you want to ask the user to enter some elements. Otherwise, the default values will be zeros because it is Calloc. If it is Malloc, it will be garbage values. Okay? Are you able to understand it or not? Now, for I is equal to 0, I less than n. Okay? So, this is your initialization, this is your condition checking, and this is the updation. Now, I is equal to 0. Okay? Now, I less than n, 0 less than 3, yes, the condition is true. If the condition is true, whatever the statements which are there in the for loop, you have to execute. So, what is the first statement? Enter the element. Let's take that user has entered the element as 1. Then, you are writing scan of %d, p plus I. What is p is consists of? 1000, which is an address. What is I value? 0. Okay? As it is an address, you have to multiply this 0 with the size of the variable. As the variable is an int, size of an int will be 4 bytes in a 32-bit compiler, so this will be 1000. So in 1000 memory location, you want to store the value 1. So value 1 will be stored here. Then again you will check the condition. Now before checking the condition, what you have to do? You have to do the increment. So I value will become 1. Then you have to check the condition. 1 less than 3. Yes, the condition is true. Again, you will ask the user to enter the element. Let's take that user has entered the element as 10 now. That value you want to store in some address location. So that is p plus I. Now look at what is the p value 1000. What is the I value? 1. So you will do 1 into 4 plus 1000, which will be 1004. In 1004 address location, you need to store the value 10. Or the compiler will do. Okay, you will not store them. Then you will increment the I value. Now I value will become 2. Now again you will check the condition. 2 less than 3. Yes, still the condition is true. Again you will ask the user to enter the element. Let's take that user has entered 100. Now scan of p plus I. Now what is the I value? 2. So 1000 plus 2 into 4 will be 1008. In 1008 memory location, you are storing the element as 100. Then I value will be incremented. It will become 3. Now look at the condition. Whether 3 is less than 3? No, 3 is equal to 3. So the condition is failed. Once the condition is failed, it will come out from the for loop and it will execute the next statement. What is the next statement? You have declared a variable called sum, which is an integer, and you have assigned a value 0. So you have declared a variable sum and you have initialized to 0. Now for I is equal to 0, now again initialization, I value will become 0. Now you are checking the condition 0 less than n, then you have the updates. So 0 less than 3, yes, the condition is true. Then what you are writing? Sum is equal to sum plus dereference operator and p plus I. What is this one? I will discuss with you. You have sum plus, okay, dereference operator p. What is the p value? 1000 plus I. I means it, as it is an address, you have to multiply. I value is 0 into 4, so it will be gives 1000. So sum is equal to sum plus dereference operator 1000. So it will go to the 1000 memory location, whatever the value is there that it is giving. Okay, that is what the dereference operator, because it is gives the value. So it will go to the 1000 memory location. What value is there? 1. So that will be written. So it is having meaning is that sum is equal to sum plus 1. Look at what is the sum value, 0. So 0 plus 1 will be 1. That value will be assigned to this variable 1, variable sum. Is it clear? Now what will happen? I value will be incremented. Now I value will become 1. 1 is less than 3. Yes, again the condition is true. If the condition is true, you have to execute the statements which are there in the for loop. Now the beginners can have a one doubt. Sir, there should be a curly braces, open curly braces and close curly braces. Remember this point. If you want to execute only one statement if the condition is true, then the curly braces are optional. If you want to execute more than one statement, then the curly braces are compulsory. So if, as I did not write the curly braces, if the condition is true, you have to execute the statement. Now 1 is less than 3. Again the condition is true. You have to write sum is equal to sum plus this 1. Now p value is 1000. Now I value is 1, so it will be 1000 plus 1 into 4, it will give 1004. So it will go to the 1004 memory location and gets that value, which will be 10. So now it will be sum is equal to sum plus 10. What is the sum value? 1. 1 plus 10 is 11. Will be stored in the variable called sum. Okay. Now what will happen? I value will be incremented. It is now becoming 2. 2 is less than 3. Again the condition is true. Again you need to execute the statement. P plus I. Now what is the I value? 2. So 2 into 4, which will be 1008. Okay. Means 2 into 4 is 8 only. Plus 1000 is 1008. So it will go to the 1008 memory location. Gets that value because you are using a dereference operator, which is 100. So sum is equal to sum plus 100. What is the sum value? 11. 11 plus 100 is how much? 111. Okay. That value will be stored in the variable called sum. Now I value will become 3. Now 3 is less than 3. No, 3 is equal to 3. So this condition is failed. If this condition is failed, it will come out from the for loop and execute the next statement. What is the next statement is there? The sum is \n. You are printing the, sorry for it, you have to write %d then \n because you have to give the format specifier. I forgot it. %d, it is an integer. So sum, what value? 311. So that value will be displayed as an output to the user. Then it is your duty to release the memory which is allocated during the runtime. So you have to use a function called free and you have to give the name of the pointer which is pointing to this memory location. So I have given. Once you have released the memory, it is your duty to assign the null value to the pointer. Otherwise, you will have the dangling pointer problem. Okay. So this is about the C program. I hope you have understood what is the Calloc and this program related to the Calloc. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will try to clear your doubts as early as possible. Thank you for watching the complete video. Have a nice day.